Okay, welcome back, friends. So in today's video we are going to be answering some more complex science paper 3, a programming section. Okay, so here's the question paper here. That's going to be section B, programming. Okay, this section, and we can see the screen very well. Okay, before we continue, I'll just create a file called main.c, and then you can see my screen very well. I'll create a file called main.c. That's where we're going to be coding. So let me open it here. Let me just open the VS Code directly here. Okay, just take some time. Okay, so here's the file. Okay, so let's read the question. So section B program says encryption is a process of transforming data into a coded form to prevent unauthorized access. A Cipher is an encryption method in which letter in a message is shifted a fixed number of positions forward in the alphabet. The number of positions by which the letter are shifted is called a key. Okay, so let's say to encrypt a message, choose a shift value, that is a key. Replace each letter in the message, that is the plain text, by the letter that is the key position forward in the alphabet. Wrap around the beginning of the alphabet if the shift goes past letter Z. Again, if you are not understanding, you better understand as we move along. Okay, so they said to decrypt an encrypted message, shift each letter in the encrypted message, that is the cipher text, backward by the shift value. This is equivalent to shifting forward by positions, that is 26 minus the key value. Now they say remark, only letters of the alphabet, that is uppercase A to Z and lowercase a to Z, are shifted. Spaces, punctuations, and digits remains unchanged. Uppercase letters stay uppercase and lowercase stays lowercase. They say to implement this, we will store the uppercase English alphabet in an array called alphabet as shown below. Okay, you can see the array. It's a one-dimensional array. Then here are the indexes starting from 0 to 25. Again, in C we start from 0, array indexing. That's why we are in at 25 instead of 26. Now task 3, which says program understanding. Number 1 says, with reference to the alphabet array, answer the following questions. They say compute the tabs below to show the calculated index before wrap around for each character using a shift value of 3. Okay, so for this particular task 3, I've already made a prepared material so as to make this video short, because at SWR making long videos tend to reduce students' attention of watching the complete video and getting the core essentials of it. So okay, here is what I already prepared for you guys. For the coding part, we are going to code it step by step. I will be coding that one with you guys. Okay, so task 3, A. Okay, they say complete the table below to show the calculated index before wrap around. This wrap around basically means if you reach at 25, right, the last index, you should start from 0. But they said before, that means we are not going to apply that. We're just going to continue with the indexes if we implement the key value. So the key value given to us is 3. That means we shift 3 steps in front, right? So the plain text A, we have capital A. Now calculated index, A is at position 0. If we calculate 3 steps in front, we have 1, 2, 3. So the new index becomes 3, so which is D. So that will be the encrypted message, right? So A, the index, that is A, the index becomes 0. Now a calculated this is the original index, right, where it is found. Now when you calculate the index, that means you add the index by 3, that the key value, right, you are going to have 3, right? Now for D, you do the same thing. We have D 4 5 6, we're going to be at index 6, so from 3 it's going to move to 6, and the value found in the 6th position is going to be after ever do you have, is it I? Yes, right. So we have A, B, C, D, E, F, G. We have G. Yes, so G is going to be there. Okay, we'll do the same. We have X here. X is at index 23. We move forward 3 steps. We have 24, 25, 26. So the new calculated index is going to be 26. You notice something? 26 is out of the bounds, right? Because our array index ends at 25, but it continues. Why? Because they say before wrapped around, so we're not supposed to wrap around here. We just have to compute till when t exceeds, right? The same thing applies for Z. For Z, the calculated index, you add 3, you are going to have 28, right? Now they say B, explain the problem encountered when encrypting letter X and Z and X and Z using key value in A above. Okay, so if you look very well, the point we encounter here is that index we have X gives index 26, while Z gives index 28, right? And the alphabet array only has value indices from 0 to 25. That's already a problem. So accessing index 26 and 27 or to up to 28 will go beyond the array boundaries. That's already a problem. So you can just write that into your exam sheet. Okay, again, I did this because for me to be typing this in the screen will be taking consuming a lot of time, but for the programming section I'm going to code that one along with you guys. Okay, so you better understand that one. So complete the table below to show how array indices wrap around after Z for a key value of 3. Okay, so for this table we have a calculated index which is 26. Now to get the valid index, right, we are going to use this method called mode. If you were in normal 2, they said let position be the index of the character in the alphabet array. Now the key be the shift value. The new position is going to be the index of the encrypted character in the alphabet array. Now mode be the modular arithmetic operator, that means the remainder of division. So we have 26 here. What we do now is we take 26 modulo 26, that is 26 divided by 26, the remainder is going to be 0. That's how we got now the value index. Again, we are using that modulo sign in able to loop again. That means when we reach 26, instead of going beyond the array size, we start again from 0, right? That's why we use modular sign. So if you take 26 mod 26, we have 0. You have that means at index 0 we have letter A, right? That's the letter that is found there, letter A here. Now if you take 27 mod 26, that means the remainder is going to be 1, so we put 1 here, and in index 1 we have B, right? We do the same for 28, the remainder is going to be 2, we put 2 here, and in index 2 we have letter C. Okay, now question Roman 2, we already did this. It says the position they said let the position be the index of a character in the alphabet array, right? So the position is simply the index that we have in this array will be the position. Now the same key be the shift value, yes, of course. So the key they give us in our case was 3, so we shift 3 times. Now new position be the index of the encrypted character. That means like for example, this is already the encrypted character for Z, right? So we take that for, is it X? Yes. So you take that, which was 23, right? You add 3 into it, we have 26. Modulo 26, we are going to have 0, and what is in index 0 is A. So this is the encrypted message. So this stands for X. A is X encrypted. Okay. Now Roman 2BA says write an expression to calculate the shifted position before wrapped. Right? That means we have to calculate this if we are not to if we are to exceed the boundary, right? So if you look at where keenly, is simply the new position, right? This new position is simply going to be equal to the current position plus the key value. So for example, if you have 20x, which is the position is 23, and the new position is going to be this 23 plus the key value, and the key value was 3. That's why we got 26, right? Now B says modify your expression so that the shifted position always remain within the value index range from 0 to 25. It gave us a hint. It says use mode operator again like we did before. So the new position in this case is going to be the current position plus the index, then modulo 26. If the number of alphabet was maybe 30 letters, right, we could have said modulo 30. So it's always going to be give the remainder when you divide that by 26, and the remainder is going to be the new position or the encrypted message, right? Okay, so continuing, we are in task 4, which says here that's where we're going to start coding. It says consider the algorithm below that accepts a character CHR and a key value and then returns the encrypted character. Okay, here's the function. You say encrypt character, which takes as parameter char and a key. CHR is probably a character, right? Now Roman 1 of task 4 says, I hope you can see this very well. They say let me zoom it. Write a pseudocode segment to compute step 1. So what does step 1 says? Here is step 1. Step 1 said if character is not alphabetic, return CHR. That means if you look through, if you check an input character and it's not alphabetic, we just leave it as it is, right, without changing. So here's the pseudocode for that. We're going to use an if statement. So if the character enter, right, is less than uppercase A, or the character entered is greater than uppercase Z, and at the same time this is an and sign, just like a logic gate. So and the character is less than lowercase v, or the character entered is greater than lowercase z, then so if it's not of these cases, then we return the normal character. That means it's not an alphabet, right? Okay, we have now the next question, which is Roman 2. The printed copy is not really that clear. Okay, but basically what they say write a pseudocode procedure called encrypt message, which takes as parameter plain text and key that accepts 2 parameters. That means the plain text is going to be a string, a character array containing the message to encrypt, and another second parameter, which is a key, as is going to be an integer shift, that is the shift value. Now it encrypts the message using the encrypt char function and display each character immediately it is processed. Okay. Now here's the algorithm already written for you guys here, so let me just explain it. So procedure, that's going to be defined our procedure, and it's going to be called encrypt message. We take as parameter plain text and the key. Plain text is an array of string, then our key is an integer. Now we're going to look through. So for I is just simply a variable starting from 0 to the length of the plain text minus 1. Why I put minus 1? Remember, we have 26 characters in our array, right? So we minus 1 from it to get 25, because remember our array indexes start from 0, not 1. That's why we minus 1 at the end. So we say encrypted character is going to be, we call this function encrypt char, and we pass the value. So encrypt char is basically this function here. So we call this function and pass in the plain text, which is an array at index I, that is the first character in the string, right? Now put comma, then the key value, in our case was 3. Now after that, remember they said here that and display each character immediately it is processed. So we need to put it inside our for loop. So we say print encrypted character here. If it was just to print after the process string, or after it has been encrypted, we could have placed it outside the for loop, right? So we end our for loop and we end our procedure. Okay, we are now into the interesting part, the programming section, right? Yes, white guys have been waiting for. 15 marks, tax 15, tax 5. It's a program implementation. The text here is not really visible. Hope you can see very well. Let's say carry out the following activities using either C or Pascal program language. Of course, we are going to be using C. That's the one used in GC, right? That Pascal, I'm sure, is really outdated. I've not really seen anybody in the GC writing in Pascal. It's outdated. I think GC should start considering maybe Python or C++. I don't know. Okay. Roman 1 of tax 5, they say declare a global array called alphabet, all in caps, which is immediately initialized with the uppercase English alphabet, right? I hope, voila. I just want to zoom in so you can see. Okay, with English uppercase one. So basically we just have to declare a global array. So let's just start. Let's first call our normal library stdio.h, our standard input output, right? stdio simply contains key statement like the printf and the scanf statements, right? So with that, we're going to declare our array called alphabets as described. It's going to be a one-dimensional array. I'll give it a size of 26. Since we have 26 letters, going to be equals to, now we pass in now our letters of alphabet, so we're going to take time. So basically it's A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay, up is correct. Again, I'm using VS Code here, but I know in the GC you guys will probably be using Dev C++ or code blocks, I don't know. But anyway, any IDE of your choice, integrated development of your choice, so far as it has a compiler, a C compiler, then you are good to go. Okay, I put all of this in order, A, B, C, D, up to Z. I hope it's in order and it's correct. Okay, that is already our 2 marks gotten. Now Roman 2 says convert the function encrypt char in tax 4 in a programming language. Again, you see, they are always going to give you algorithms for you to convert into C. Just one thing you should master before the GC. You guys are already on the 15, right? So just try as multiple pseudocodes as possible, converting them into a program, into a programming language like C. Okay, so to convert that, we first of all, it's a function, right? So it's going to take in as parameter a character and a key. So this function is actually a character function, right? So I'm going to say char and encrypt char like this. Then I pass in the value going to be a character CHR, comma, then int key. Okay, now it says step 1, if character is not alphabet, return the character. That means you don't change it. Now in order to do this, we are going to use one inbuilt keyword in C, which is called alpha. Why? Because there's no need for us to be computing this manual method if C already contains library for us to do that. And in order to use that is alpha, we need to include an additional library. Let me make sure. We need to include one additional library called C type. So I'm going to say hash include C type, right, .h. So with this library we'll be able to use this keyword. So I'm going to say if exclamation I, which means stand for is not. So if, I hope you can see my screen. Let me just zoom it. Let me zoom. Okay, so if is alpha, is alpha, we pass in CHR and we check this character here. If it's not alpha, right, we simply return CHR. Okay, so but that's basically what this step 1 does. So if the character is not an alphabetic, we return the character. So this is what is alpha does here. Sorry, is alpha, it doesn't contain R here, so just like that. So if alpha is not a character, it's not an alphabetic, if this character CHR, we are passing in parameters is what we are checking. So if it's not an alphabet, we return the number with the letter without changing. Right now, step 2 saying convert character to uppercase. Again, we are going to be using this library C type. So what this C type does is that it contains keywords or statements in C that we can check if the number is alphabetic, we can convert to a lowercase, we can convert to a uppercase. Okay, so maybe I should comment our code so that will be clearer. I can say here, let me say this is step 1, right? Okay, step 1. Then now down here I'll comment, let's say step 2. Okay, we are good to go. Now step 2 same, convert character to uppercase. So if character is lowercase, then we set is low. This is probably a new variable, we are going to declare it. We say is low equals to 1, and we set upper character is going to be equals to the converted character to uppercase. Else, in fact, as I'm doing, let me be typing it. So step 2, we are going to say if right is lower, this keyword is coming from that library. So if it's lower car, it's not actually a CR. I don't know why they named that variable like that. They could have given a different name. It's kind of, it can create conflict with this normal character data type. So if it's lower, right, what do? If it's lower, we set is lower equals to 1, right, and this is lower has not yet been declared. So let's type, let's say is lower equals to 1. So in order to use that is lower, let's come at the top of this thing here and declare it. It's an integer, right? So I'm going to say int is lower. I want you guys to take note here that this is lower. The L here is capital, so it's not the same as this one. If you put it as the same as this one, then it will create a conflict. It's like you are using a keyword in C library that is already in C library. So this is lower is different. So another cool thing we could do is set this is lower, maybe the default value of 0, starting from, let it be 0 at default. So before we start manipulating it, now we said we set is lower to 1. Now we said upper car is actually another variable that we need to declare. So we said upper car equals to convert to uppercase. So before we use upper car, let me just include it. So upper car is probably a character. So upper car, right, like that. Now we said that we set our upper car this is how it was spelled, right? Upper car is going to be equals to, again we're going to use this keyword in C, which is to upper, and we pass in CR. So again, this to upper is coming from this library C type. So you can see you need to know some kind of libraries in order to facilitate your work when you're coding. So this C type .h library, like I said in the very beginning, you can convert a character to lowercase, and at the same time you can check if a variable or a character is a alphabet or not. Okay, so we're going to convert this. We're going to take upper car, which is a variable, and we assign it to this variable. We are going to change the character to uppercase, right, and store it in this variable upper car. Okay, so next step, now we have else, right? So that's, we have else is lower equals to 0. So is lower equals to 0. Again, we are using this is lower that we have that has been declared up here already. Now is lower equals 0. We say upper car equals to car. So we said again, come now down here, we have our upper car. The C is in caps. Upper car equals to CR. Okay, that's it. Now we end our, we say and if, okay, yes, we end it here. Now step 3. Okay, where am I? Okay, so we have step 3. We move on to step 3. Now step 3 says find the position of the character in alphabet. So we just have to be converting this pseudocode into a program language. So in that one, step 3, it's a for loop. So we're going to say for, from I starting from 0 to 25, right? So for, I'm going to declare the I inside the parentheses. So for I equals to 0, right, I strictly less than 25, then we increment our I plus plus. Okay, now what do we put inside? They said we use an if statement. So if, again we are here, so they say if alpha, that means the array alphabet. If alphabet, right, we pass in the parameter I. If is equals to, that is upper car, like this, right? What do? They say we set the position to I. So So this position is also a variable that has not been declared. So position equals to I. Okay, one thing to note here is that when you are comparing two variables, here in algorithm they just put one equals to sign, but when you want to compare something, like if this is equal to this, you use double equals to sign. Now for this variable that we have not yet declared position, let's come at the top here and declare it. So int position, so that they won't disturb us again with that error. Okay, now one good thing to know is that since we know that our positioning start from 0 to 25, to help us debug our code very well, you can give a default value for position as -1. All developers always do this in situations like this, so that if you know that no matter what, our position can never be -1. So this is a valid way to easily debug your program. If you set it to -1, you know that no matter how the program functions, your position can never be -1, because only from starting from 0 up to +25. So if there's a problem with your code, you know that you can easily come and debug it, because we set our default position to be -1. Now here we overwrite it. I can just maybe comment it here that overwrite override position, so from -1 to I. Okay, now next let's say we end our if. Okay, I did not put our if in with parentheses. Again, in C, when you just have only one if, like you don't have if else, you can just do it without parentheses. But if you have multiple, you can do with parentheses. Again, a C function like this in C. So this if, we already end our if. Now we end our for. This end our for. Now step 4. Let me comment it. Step 4. Okay. In step 4, it says calculate the new position in alphabet. It says use the final expression in task 3. Remember task 3 Roman 2, right? Here is task 3 Roman 2. So we're going to use this formula, right? So it's going to be easy to implement. Okay, so that's our task 4, right? So implement that. Remember we used, where's that place? We said task 3 Roman 2 was new position equals to the current position plus the key modulo 26. Okay, so what we do is that I'm just simply going to say new. Again, this is a variable that I'm going to declare at the top, so I can say new position. I'll declare it later on at the top. So I can say new position equals to, in parentheses, our position that we know, right, plus the key. Even the key, we need to declare also the key, plus the key. Then now modulo in C is percentage, right? So modulo 26. Okay, now new position, and this, let me copy it. We need to declare it up here where we are declaring our variables. Alright, so going to be an integer, new position. Now we also need to declare our key, right? If I'm not mistaken, okay, no, our key has been passed inside this Cipher, inside this encrypted car as a parameter. It has been declared already in here, so no need. Okay, what next? We have step 5, which is return encrypted character. Okay, so we move on to step 5. Let me just do this and comment it. That's going to be step 5, which is returning the encrypted character. So we say if is lower, let's say if is lower equals to 1, if is lower equals to 1, what do? Let's say we set the cipher car. Again, this cipher car is a new character that has not yet been defined, but anyway, cipher car set it equals to say to uppercase, right? We'll convert alphabet new position to lowercase, so we're going to be lower like this. Again, this keyword lower is coming from the library hash include c type.h. If not, you won't be able to use it. So to lower, right, then I will pass in the parameter is going to be our alphabet, and the index is going to be the new position that we calculated. So new position. Okay. This is in parentheses, in square brackets. Okay, we are good to go. Now this cipher, we need to declare the cipher because we are using it without it being declared at the very beginning. So I'm going to say it's a character, so I'm going to say car cipher car. Okay, the error is gone. So make note, in most of the algorithm they just use variables without actually declaring them. I want to think that no, they have to declare this variable that I'm using, right? Okay, so after that we say else. Okay, so there's an else after that. So else, right? So else cipher is going to be given alphabet the new position. Okay, again the logic has been written for you just for you to convert it. So else cipher car, right, is equals to alphabet square brackets new position, just like that. Close to that semicolon. Okay, after that I said and if, as we are ended our if. Again, I'm not putting it in curly brackets. You could still do it in curly brackets. So but in this way, in C, you put it this way, it still works also, but maybe some old IDEs may not prefer it. So I recommend you put it in curly brackets, or you can see write it as I'm doing. Okay, so our end if statement ends here. Now let's say return cipher. Okay, so after our end if, let's say return. Now you know why they gave this as a function. Like I said before, functions, they return values, right? So at the end we just return cipher because it's a function. So all our time we are still been coding inside this function called encrypt car, right? Okay, continuing, where we are converting the function encrypt car. Now that we are done with it, we have from 1 to 3 which says convert the procedure encrypt message in a program language. Okay, now the procedure encrypt message, we did it in Roman in tax 4 Roman 4. So we need to convert this pseudocode into a program language. Okay, So let's just look at it. So it's going to be a procedure, and we've taken parameters, a plain text which is going to be an array, a key, then a for loop that will iterate and up to the length, and it's going to encrypt the character by passing the encrypt char function that we just did here. So okay, let's just code that by the way. Okay, so since it's a procedure, I'm going to say void encrypt message. So we pass a parameter plain text. That plain text is going to be an array. So plain text, put it curly bracket since it's curly bracket since square bracket since it's an array. Then now we pass our key. Remember it took a key. Open our curly braces. Now we use our for loop just as it is here. That is going to iterate up to the length of the text. That means the length of the message or whatever character is being sent. Okay, to do that, we are going to first of all calculate the length of our text, right? So I'm going to create a variable called len equals to, again, I'll use one keyword in string again to calculate the length. Is called string len. So this string len will pass in our plain text, right? And again, in order to use this string len variable or string len keyword in C, you need to include another library called string.h. So I'll just say hash include. Again, you see, before I use a library or use a keyword, I include a library for it. The same like for SWR, if I want to use the printf and the scanf statement, right, I need to include this library SWR.h, which stands for standard input output. Okay, so I need to include string.h library, okay, in order to use that string len. So this len, this will calculate the length of the text and put it inside the variable called len. Okay, so after that, we're using our for loop to iterate. Now I'm going to declare the integer inside. So from int I equals to 0, right, I strictly less than the length, that's the string len, right, then I plus plus. Okay, now in it, now remember from our procedure up here, again we are just following this procedure. We say encrypted char, right, is going to be equals to the encrypted char plain text. You could do this in one line, or maybe declare a variable. Here we declare a variable called encrypted char. Anyway, let's just do it by the way. So here, I think let me just declare a variable here. It's an encrypted char, right? Okay. Encrypted char. So this encrypted char in here, you can just say the encrypted char was equals to, let me check again, was equals to we passing now the procedure or the function encrypt char, which is this procedure. So encrypt char is going to take the parameter of the plain text with the index I, which is iterating, and the key. Okay, so encrypted char is equals to encrypt char, right? Encrypt char with parameter the plain text is going to take as index I, comma, then the key, right? I think we should do this inside our for loop since we're using I, and I is inside, not outside here, so it's better to put it in here. Okay, like this. Okay, it makes sense now, like this. Okay, so after that, now what did we do? Okay, we print out the encrypted character. So here we can now use our printf statement. Again, our printf statement is from the stdio.h library. So printf, since it's a character, it's a percentage C, right, comma, then encrypted char. Okay, if I'm not making a mistake, yes, it should be that, right? So the encrypted char stores what is being passed through as parameter inside our encrypt char function, which encrypts it, then store it in this variable encrypted char. Now there are two different. This one is encrypted and this one is just encrypt char. Again, you could still do in one line, but just to make your work easier, we do that. Now to print our work very well in the screen, I will suggest we have another printer statement here that kind of help us go to the next line. So /n to format our work correctly. Okay, so after that we print f next line. Okay, that was implementation of Roman, where are we? Roman 3. Okay, Roman 4 says write a main program that prompts the user to enter a message, prompts the user to enter a key, calculate encrypted message, procedure to encrypt. Okay, let's just do that right away. So since that time we are still writing the procedures, we haven't written the main program yet, and this one is a function, right? Why is it function? Because if a function returns values, that's why we have return 0 at the end of main, right? So int main, I'm going to start from the beginning. Okay, so our int main, we are going to, let's say, prompt the user to enter a variable, to enter a message, right? So program say print f, I can say enter a message, right? Enter a message. Okay, give them enough space outside here. Okay, after entering the message, after this text to enter a message, instead of using normal printf statement, I'm going to use fget. It's another keyword that you can only use it when you include this library string, and I'll tell you why I'm using this fget instead. Because here you look over at Roman 5, they said making sure your program runs, enter the message computer science gives inside. So if you look over, there's a space here and there's a space here, like it's a long sentence with a space, like a phrase. But if you use normal printf statement, we'll just takes everything in into one, it's like a one word, right? But we need to separate it with spaces, and to do that we need to use this keyword fget. So that's what fget does. So the format of fget is that we first of all pass in the source. It's going to be our message. Again, we need to declare the message and we calculate the size. Before we do that, let me just declare the message by the way. Anything we use, let's just declare it. So by the message is supposed to be a character, not integer. So int message, what should be the length? In this case here, we have computer science. Computer science will be like 20 characters. You know what? Let me just put 100 as a size. So the message is going to be an array of size 100. So here going to be the source, which is message. Then we'll calculate now the size, so that give a limit, so that the user should not enter something that is more than the size, right? So the size of, pass the value message. So we're going to calculate the size of message. Then now we're going to use std in. This std in simply it's like taken from the keyboard, right? So we're going to input from the keyboard, calculate the size, and we're going to store it inside this message array, right, of size 100. Okay, and with a semicolon. Now after that, now we need to to remove some trailing trailing new lines, because when we do that, when we use this format, this fgets, there's an enter, there's a new line, like when you press enter, right, a new line is being created. So we need to remove that new line by using, we're going to type message and use this keyword as a string I think it's compare span or completion span. Yes, string completion span. If I'm not mistaken, it should be like this. String completion span, like this. Yes, and we are going to pass. By the way, this message was an array, so pass square bracket. So when we say that completion string completion span, we pass now our message, right, and the last that means the enter key, that is the new line, right? You remove it and give it a terminator value. So when we say /n new line, we are going to, this is supposed to be inside curly braces, square bracket, okay, like this. Okay, so we give it a new we give it a null value, right? A null terminator. Now in C, a null character is often represented as /0, right? This is a new character, a null, like null as in, so /n, all of this is supposed to be, let me cut it. This is supposed to be inside that our brackets, like this. We'll cut it and put it inside here. Okay, like this. And we'll just, okay. So what happens here is that when a new line is created, right, we use this string completion span, which takes that new line and give it a null terminator character. So I can comment it like null terminator, like this. Okay, so that's basically what it does. Okay, now let's say from the user to enter the key. So after entering the message, we need to ask the user to enter the key. So I can say that printf, we say just say enter key, right? Enter key value, something like this. Okay, then with a semicolon. Now we're going to use our normal scanf here. Scanf. Going to the key value is a integer, so going to be %d, comma, ampersand key, right? I think before we use this key, we should declare it, yes, because key is not global. So key is going to be an integer key, Okay, so we're going to store that in a semicolon. Okay, and that's it. Let's return our 0 since it's a function. Return 0. I think we should be good to go. There's an error here, so we have message. How many column? So one bracket here. Okay, I'm gonna make a message here. So we have f gets. We pass in our message. We put in the size inside message. So message is a closing bracket here. Then now we say SG. Okay, the error is gone. There was a miss. Like we switch the values, the parentheses. I think our program should be good to go. We need to compile, run, and test it. Okay. So let me just open a new terminal here. Let me zoom it. Let me navigate where my program is. I think it's inside control science. LSCG, I think it was 0795 okay, that's the program then. So let's compile and run it. GCC, that's the name of the program is main.c -o main.c main. Okay, and now there are errors. There's been this collection error return. Is this did it compile? No. Let's go back to our main program. Where could the error be coming from? It says user being GCC. Is the energy user correct? GCC main.c -o main. In function start is it undefined reference to main. Let me check again our codes. Int main. Our main index here. Okay, they said call encrypt message. Maybe that's probably why we just ended here without calling the. We enter the key, but we do not use the key and the message. So they say call encrypted message procedure to encrypt it and display. Okay, so actually we do not even encrypt and we do not even display, right? So we just encrypt. We just took the message. We took the key, but we did not encrypt. Okay, so let's encrypt. I'm going to say printf percentage. Printf is going to just say encrypted message. Okay. So to print out the encrypted message, I'll just call the function encrypt message just as set here. So I'll just call that procedure, which was encrypt message. Then pass the parameter, the message, comma, and the key, like this, right? That should be correct. Yes, because it's a called encrypted message procedure. Okay, here's the procedure here. Encrypt message. Everything should be good to go now. Then we come back to our program. We clear the screen. Then we compile and run again. Okay, it runs successfully. ls, you can see the one in green here is a compile one. So to run it, /main. Okay, enter a message. In our case here, let me shift this screen to where we are. I think I should. They said the message. Let me clear my screen here. Oh, we'll cancel the program and start again. Let me run it. Okay, so the same. Roman 5 said, make sure your program runs. Enter the message. Computer science gives insight. To encrypt it, print the output and save the source code as Cipher and print the copy. Okay, enter the message. I'll just say computer science gives insights. Indeed, computer science gives insight. The key value is going to be 3. Wow, it is not displayed. Wow, interesting. What could be the problem? I think we can navigate that. So we will go back to our encrypt message, pass the value, message and the key. So what could we become from? Or is it more than the size? Let me increase the size here. We'll put 200 for example, and recompile the program again, then rerun it. Let me first clear my screen and rerun it. Computer science gives insight. Key, we give a key of 3. The same thing. Let's just look through the encrypt message algorithm. We have encrypt message, plain text, which the key, the length is, I think the error should be coming to the level here. Is it how to define an array of string? I think I was supposed to separate this in single quotes. I think like this. I don't know. Was I supposed to do it like this? No way. I think it should be, since it's an array, I should put this inside curly brackets like this. Then now I put now each letter, each single alphabet in a single quote. So cancels A in single quotes. I put in single quotes. I put comma B in single quotes. Then first I put the single quotes all throughout before I come back, put in a comma, single quote, single quote, single quote. I just hope this works, because there should be an error in the way we declared our array of the number of alphabetic order, right? Okay, now let's start putting my bed comma to separate the work, right? So this one comma, this one doesn't have single quotes. Oh, this one's with double single quotes. Oh, this is taking a lot of time, but anyway, you see what in re-exam where you can go through. It's supposed to come before. Like this. okay, there's no semicolon here. Let me reduce the screen size. Okay, we should be good to go, right? This last one, should I put I don't know whether this requires actually this is where we put also say we should be expecting somewhere voila here. Voila, the error is gone. Let me save, compile this program. Run it. I'll just copy it and paste so I will know what's done. Let's have this fun. Key, I'll give it 1, 2, 3. Wow, is it giving the same issue? Actually, I don't know what could be the possible problem. Let me look again into this. It should be coming from the encrypted message. I don't know why it's not visible. So the encrypted message function or procedure, this one here. Okay, so in the encrypted message we pass in a character which is plain text, right, an integer which is a key, then now our int len, which is a string len of the plain text. Now we take from I equals 0 to I less than the length, we increment our I, then int encrypted character, we gave it encrypt char plain text I key. Got a mistake here. So encrypt character, no, it's correct. Now printf %c comma encrypt char, then /n for next line. That would be possible for us. Let's look at this encrypt char. It's like we made a mistake in our encrypt char algorithm. Our encrypt char will get this this position, no position, cipher, then it's lower. I don't know why it's not displaying correctly. So it's lower, check 1. So return this, is lower, return 1. To open this else is lower, is 0 car, then for I less than 25. I think this is supposed to be less than or equals to. Yes, if not, maybe that's an issue. It should be less than or equals to. Should it be strictly less than? Let's try it again. Compile on. Wow, it still doesn't work. So it's less than or equals to 25 here. Yes, it's going to start from 0 up to 25. Yes, so uppercase I have upper car. We have position, we give it position I, then your position, which is position plus key, 126. Then if is lower equals to 1, we set our cipher equals to alphabet, new cipher, just like that, return our cipher, Where could the error come from? I've gone through. Where can it come from? I don't know why is this it's not visible. Or is it from this string get? We have our fget, our message, the size of the message, and std in the message string span, the message /n, give it the new character n, then enter key, %d, %key, print the encrypted message key. Seriously, I've gone through it. I don't know where this can possibly be coming from. Where can it come from? Where can this sit that should be in this? Anyways, just to make sure our program doesn't, our time, I don't consume our time a lot, at least we can answer a lot, most of the question. But if I find an issue why my encrypted data is not displaying, I'll probably mention it later on. Alright, the correct version is going to be on my GitHub account. So again, thanks for watching, and you can also take it as a challenge to see and debug and see why the encrypted message is not visible, or is it because it's in my machine? I don't know. Just try and run it and see whether the encrypted message is going to work in your machine. Again, I'm still kind of worried. Why? Or is it the size that I gave here? The size is 26. Where could the error come from? I have no idea. But the program works perfectly fine though. Just that I don't know why this encrypted message is not visible. Encrypted message, let's see something. So encrypted message function is good. It's supposed to display a message. Encrypted message, pass message. Let me check encrypted message a bit. Yes, encrypted message. %c. Yes, %c. We have encrypted car. Is this? You know what? What should I do? Let me try and remove this and put it inside one sentence. It might work. Let me take all of this, Control X, and put it here. Though I don't really see a difference. Anyway, just for testing purposes to see whether actually there's a problem here. This. So printf for I equals to 0, I less than this. I don't know why my answer is not. Why is it not printing? So this is a statement that's supposed to print that result. %c encrypted car plain text. I don't know why. Let me enter. Just enter normal text. Let me see. Z. And I enter imperative as 3. But it worked. It worked for Z, but what about the string? It works for only one character, right? So if I enter computer 3, while it encrypts, but if I enter, for example, computer science, so actually the program works. But it's as if it's not working for longer string. Maybe it's from this fget statement. maybe I did not complete it very well. std in because I want to handle the spaces. Let me see, message -m, this is because the no character. I don't really know. No, let me enter a message. Computer science gives insight. Key 3. Wow, it works. Like, what the heck? Where is the error code? Surely it should be this. I don't know what happened, but when I changed from that character that was storing it to here, it works. Oh, it's as if I see. Like, it was not showing like because we had one character that was holding one string, and the string contains spaces, so that's why probably was showing that, if I'm not mistaken. So we need to pass all of this inside one in the same printf statement, not storing inside the character, because the character was just a variable, and that variable was probably supposed to be a string that contains a long characters. Like, I don't know where I get my point. We are not supposed to store this inside a single variable, right? Either we store it inside an array, like the message array, or we just print it inside our print statement in one line. But basically, since our program works, everything is cool. So this video already too long, and I hope you enjoyed it and learned a lot from it. So the rest of the source code is going to be available in my GitHub account, and for other videos also. In fact, it's one GitHub repository that contains all my source code for concerning GC, June, and more computer science preparatory questions and answers, right? So you can go to I'm going to provide a link below. This video is too long. Okay, so see you next time. It was too long because of that silly mistake that we had. Ciao, Mr. DCT.